So somebody tell me how this problem is different from the last time we worked problems like this. There's what?
There's an X.
Well, remember we had X's in our other problems, didn't we?
Yeah, you're right. And it equals something.
Well, we had an equal sign in our last problems, didn't we? What we didn't have is that. We had something like this, right? Where we would cross multiply to solve. Remember that? We didn't have something added or subtracted to one of the other sides. So today's problems are going to be like this. They're going to be different because we cannot use cross multiplication to solve them. So let me ask you this. If you were given a choice, would you choose to work a problem containing a fraction, or would you choose to work a problem that doesn't contain a fraction? That seems almost a silly question, right? Almost everyone would rather choose problems that didn't have fractions in them. Well, guess what? Me too. I'd rather not have to deal with fractions if I didn't have to. And the way I'm going to show you how to solve these today, you don't have to. You do not have to deal with fractions. Okay? When we added and subtracted before, it did look like this. You were correct. This was a problem that we would work before. And what we would get, because it is an expression, what we would get is like another fraction as our answer, right? We found a common denominator and got a common denominator, right? Well, this time, when our problem looks like this, we're going to find a common denominator, and we're going to use that to become denominator assassins. Now, we're not going to get paid for it, and there's not going to be any blood involved. That I know of. Okay? Then why would you want to do it? I'm sorry. It'll make the problem easier. How about that? Okay? So look at these denominators that are here and tell me what you think would be the common denominator. What's your first instinct? You got to have an X, right? For sure you have to have an X because two of the denominators have an X. What does this one have, though?
4.
A 4. So doesn't that also have to be part of our denominator? Okay? So if I have a factor of 4 and a factor of X, doesn't that cover all the factors in the denominator right now? So remember I told you, so we've decided our common denominators can be 4X, right? What I told you is that we're going to use our denominator to eliminate the denominators. We're going to become denominator assassins.
Yes.
Okay? So instead of getting a common denominator, we're going to get rid of it now. We're going to multiply both sides of the equation by 4x. Now, we're going to skip a step, and I can skip a step as long as you understand the step I'm skipping. Okay? I multiply this whole side of the equation by 4x. What would happen if I multiplied this whole side of the equation by 4x? Wouldn't I have to distribute it to each term? So can I go ahead and, when I write it, distribute it already to each term? Can I do that and you understand the math behind it? Okay. Now, how in the world does that actually help me eliminate the denominators? What happens to these x's? What is x divided by x? 1. That simplifies to 1. What's left? 20. Right? 5 times 4. What happens to these 4s? They simplify to 1. What's left? 7x. What happens to... Oh, these x's? They simplify to 1. What's left? Negative 36. Which problem looks easier? This one or this one?
The bottom.
The bottom one. That's because it is. There's no fractions. How do we solve this problem?
Subtract 20.
Perfect. Subtract 20 from both sides. 7x equals negative 56. Next step.
Divide by 7.
Divide both sides by 7. X equals negative 8. Is it right?
Yeah, I have to check it.
We have to check it. 5 over negative 8 plus 7 over 4 equals negative 9 over negative 8. Well, first of all, I'm going to move this negative sign to the front of the fraction and not just in the denominator. You okay with that? Next, I'm going to know that negative over negative is, what's a negative divided by a negative? Positive. And then I'm going to make this 14 over 8. Anybody have a problem with that? What's negative 5 plus 14? 9. Does it work? Boom. That's my answer. Questions? Notice, where did I go to put my answer in when I found it?
X.
Did I go here?
No.
Where did I go? To the original problem. Okay? Keep that in mind, please. It may make a difference at times. Okay? Any questions about this example? Do you have it copied? Let's do this one. Whoa. Remember, when I'm dealing with common denominators, I can only deal with factors. Things being multiplied or divided, mostly multiplied, though when we're talking about factors. Not added or subtracted, though. So what do you think my common denominator would be for this problem? X minus 5? Okay, so how do I make this become x minus 5? But we just said it has to be a factor. You have to multiply or divide something. Mostly multiply, not add or subtract. And you're telling me now I have to subtract 5 to make this become the same factor as this? I can't do that. What do you think? What do you think my common denominator would be?
If you add 5 to the 8 plus 5, would that get rid of that 5?
So same kind of thought process as a minute ago. And I'm dealing with factors. I have to say what multiplies to get me the other one. But you're saying to add 5 to this one, I can't do that. It's a good thought, but we can't do it because we can only deal with factors. Factors are not things that are being added or subtracted. Remember when we were doing a problem like this, where it was just an expression, we said when you're in doubt of how to find the common denominator, what should you do? Multiply the denominators together. Guess what the common denominator is of this problem? X times x minus 5. Okay? So I'm going to multiply every term times x minus 5. Just like that. So what am I left with in the first fraction? What simplifies? What simplifies here? Oh, nothing? Why not? Yeah, because there's not already a denominator. Okay? So I have x times x minus 5. What simplifies here? If anything. X minus 5's. What's left? Minus 8x. What simplifies here? If anything. The x. What's left? 3 times x minus 5. Is this a problem like you've seen before? Where? Algebra 1? Yeah? Or when we talked about quadratics earlier this year? Remember that? X times x is x squared. X times negative 5 minus 5x minus 8x equals Good. 3x minus 15. Now it is a quadratic, so we want it to equal 0. Good. I like to keep a positive x squared term. That's just me. So if I was doing this problem, and I am, oh, I don't want to do that yet, do I? What do I want to do first? Yeah, good. Simplify our like terms. So x squared minus 13x equals 3x minus 15. Now I want to add or subtract 3x from both sides, and I want to add 15 to both sides. So I end up with x squared minus 16x plus 15 equals 0. Now what can I do with that? AC? Okay.
It's to be 1 and 5 negative.
You want it to be what?
It'd be negative 1 and, oh, not 1 and 5, 1 and 15.
1 and 15? Negative both of them. So x minus 1 and x minus 15 equals 0. Good. What do I have to do with each of those factors? Good. Set them equal to 0. X minus 1 equals 0. X minus 15 equals 0. X equals 1. X equals 15. Are they right? Check them. Let's check the 1 first. Let's say 1 minus 8 over 1 minus 5 is negative 4 equals 3 over 1. 1 minus negative 2 equals 3. God bless you. Is that true? How's that true? Oh, yeah, I forgot about that. Not really. So that one works, right? One works. 1 minus 8 over 10, because it's, excuse me, 15 minus 5 is 10, equals 3 over 15. Well, 10 over 10 minus 8 over 10 is 2 over 10, right? 3 over 15 simplifies to 1 over 5. Is that true? Oh, yeah, sure is. X equals 15 works as well. You want one more easy example, or you want me to jump in with both feet to the hard one? All right. And you know, if I'm telling you it's hard, is it really hard?
Yes.
No, it's not. I usually don't tell you if it's hard. We just do it. This one's slightly different, however. Why? Before I can even start, what do I need to do? Factor the denominator. This one's already factored. I'll let you copy it down. Sorry. All right. Is this one factored all the way? Is this one factored all the way? Is this one factored all the way? So it's just this middle one that we have to factor, right? What does it factor to? Oh, look at that. X plus 3, x minus 3. It's a difference of squares, isn't it? God bless you. If it's the difference of squares, that makes it really nice. What do you think our common denominator is going to be? We got to have all the factors that are there. So I need an x minus 3. Well, this one already has an x minus 3, so that's nice. I need an x plus 3. Well, this one's already got an x plus 3. So what's my common denominator? X plus 3, x minus 3. X plus 3, x minus 3. X plus 3, x minus 3. Good thinking. What simplifies in the first fraction, if anything? X minus 3, x minus 3. What's left? 6 times x plus 3 equals, what cancels? Oh, excuse me. What simplifies, if anything? X plus 3, x minus 3. What's left? Yeah, just 8x squared. What do you think? X plus 3 minus 4x times x minus 3. Now, I just did something very deliberate, and I want you to know what I did. I know at some point, some of you guys are going to get quicker at this, and you're going to want to do multiple steps at a time. You know I don't care about that as long as you understand the math, right? And some of you might have wanted to go ahead and multiply this out already right here, just seeing it, and write 4x squared, right? That and that. The problem is, if you're going too fast, you're going to write like minus 4x squared plus 12x. Why is that wrong? Excuse me. Minus, let's see, 4x squared minus 12x. Why would 4x squared minus 12x be wrong? Yeah, because of that subtraction sign right there. That's why I deliberately wrote the 4x, and I deliberately wrote the factor that I'm multiplying it by, because I needed us to remember that we have a negative sign right there, a subtraction sign right here. Okay? So what we need to do now is just go ahead and simplify. We need to distribute here and here. We need to distribute here and here, remembering that sign right there. Does that make sense? Okay. So we get 6x plus 18 equals what? Good. 8x squared minus 4x squared plus 12x. Where do I want everything? What do I want to do? Here? Combine those two? All right. 6x plus 18 equals 4x plus 12x. Oops, I forgot my squared. Sorry about that. So if I subtract 6x from both sides and subtract 18 from both sides, that'll get me equal to 0, which I need because it's a quadratic. 4x squared plus 6x minus 18. Has anything that we've done so far been hard? It's a bunch of simple steps. But what happens if you miss one of those simple steps? You are doomed. Okay? That's why I'm taking so much time to write down every single step for you to see, to make sure you understand the process. Okay? Guys, really the hardest thing, the thing you guys have had the most trouble with so far, is just finding the common denominator at the beginning. You know how to do all this stuff, don't you? Then let's keep at it, because that's what kind of people we are. We don't give up. Okay? Now, I'm not saying I want to give up. I'm saying I want to make this problem easier on myself. Is there a way to make this problem easier on myself from here? Yeah, you noticed the same thing I did, right? All three of these terms are divisible by 2. Right? So can I divide everything by 2? Like that? What's 0 divided by 2? 0. 4 divided by 2 is 2x squared plus 3x minus 9. Yeah, that makes it a lot easier, doesn't it? It's a trinomial. Should I try to factor it? I could use quadratic formula. I could use my graphing calculator by looking at the graph and looking for the x-intercepts. I could look at the table and look for where y equals 0. Okay? Some of you were looking at me like, oh my gosh, that's exactly what we did last time we met. And I'm like, I know. I'm glad you see it. That's excellent. So I need to do AC here, don't I? AC is negative 18. B is 3. What two numbers multiply to be negative 18 and add to be positive 3? 6 and 3. Negative 3. Very good. Okay? Yeah, you got it? That's okay. All right, so I need to rewrite this, don't I? I need to split my middle term into these two parts. So I have 2x squared plus 6x minus 3x minus 9. And this still equals 0. So I need to factor this by grouping. Remember how to do that? Of course you do. You're geniuses. 2x, x plus 3, negative 3, x plus 3. What do you think? Can I still keep going? Good, do it. What are my two factors? 2x minus 3 is one factor. X plus 3 is the other factor. To solve, we're almost there. To solve, what do we do? Excellent. So if I add 3, we get 2x equals 3. X equals 3 halves. X equals negative 3. Now we can just assume they're both right? Because we've done this so many times, we know we have to be good. No. Where do I go back to substitute them in? The very beginning, right? The original problem. Okay, so 3 halves. 3 halves is 1.5, right? 6 divided by 1.5 minus 3 is negative 1.5 equals, we got our calculator, right? We're going to have to square some really hard numbers like 1.5. I know, I'm just teasing. What is 1.5 squared? Do you know what 15 squared is?
It's 30.
Man, I wish we had some calculators to work this out with. Oh, yeah, we do, don't we? Yeah, good idea. Yeah, if you don't have yours, make sure you get it. You're supposed to get them every day when you walk in. Trying to make this faster for you, and you're making it slower. 2.25 times 8? That's all right. I didn't ask you that yet. 18 over 2.25 minus 9. Say it one more time. I'm sorry I couldn't hear you because somebody was talking. Negative. I still can't hear you. I'm sorry.
Negative 6 minus 7.
Thank you. Minus 4 times 1.5? 6 over 1.5 plus 3, so 4.5. Well, how am I going to figure out if that's all equal to each other? I mean, do I just say, yep, it's probably right because it looks right? No, I can't do that, can I? Figure it out. Use your brain. Let's see if I can remember how to do this, and I want to show you something. Okay, let me show you this real fast. I don't know if you know that this is possible, but I want to show you just in case you didn't know. I'm just going to type this whole thing in. 6 divided by negative 1.5 equals 18 over negative 6.75 minus 6 divided by 4.5. I put everything in right? Yes? Watch what happens when I press enter. True. I don't have to know what all these fractions mean. I just know that it's true. Now, it's nice if you know what they all mean, what they all simplify to. But if we're worrying about time and we already understand the math of what's going on, is it okay to use a calculator this way? Yeah. Okay. What about this other one? Okay, so we figured out that this one's true, right? That one works for sure. What about this other one? X equals negative 3? All right. 6 over negative 6. Well, that's nice because that's an easy fraction, isn't it? What is negative 3 squared? 9 times 8? 72. Let's see. 3 squared is 9, so 9 minus... Negative 3 squared is 9. 9 minus 9? 0? I must have done something wrong.
No.
Right? Are you sure I didn't do anything wrong?
Yeah.
Because see, what happens, what I get here is negative 12 over another 0? So if I would have thought about it from the beginning, I would have realized that this value is not permitted in our domain, is it? Why is it not permitted in our domain? Why is it not permitted in our domain? For both of these denominators, it makes the denominator 0. And who's allowed to divide by 0? No one. Chuck Norris, but he's not in this class. Okay? So, what do I do as far as this one goes? I mean, just do I circle it, or what do I do? Oh, I mean, I just cross it out? And then put a frowny face beside it? Yeah. What's our only solution to this problem? X equals 3/2. I got another one, but it is not allowed in our domain because it makes our denominator 0. Okay? Any questions? How are you feeling about this? Confident? Medium? You want to throw up? Okay, I do have 2 trash cans, so I think we're okay. But the rest of you are feeling fairly confident? Good. Keep it up. Ask questions if you need help. Otherwise, go ahead and get to work on your homework.